Hello guys, we are from group 1. First, let us introduce ourselves. My name is Chatarina Mauren and my partner.
My name is Yuslia Irawati.
My name is Anifa Mirza Liadiani.
Now we will discuss about complex number, especially in
Polar form,
Exponential form,
power and roots of complex number.
Now we will learn about complex number. Complex number can be stated as three forms. The first one is Cartesian form, and then polar form, and the last is exponential form. As we know, complex number is an ordered pair of x, y. So the Cartesian form is let Z be complex number. So Z is equals to x plus iy. So this is the Cartesian form of complex number. But our focus is not in Cartesian form. Our focus is about polar form and exponential form. How we can state the complex number into a polar form? Okay, now we will discuss about polar form of complex number. Let Z be a complex number with Z in the coordinate x, y. So if we want to change Z into polar form, we must change the coordinate of Z into the coordinate r, theta. Now let's see this Cartesian diagram. Since C is in the coordinate x, y, so we can put C as a dot here, and we can make the projection of Z into each axis, that is y-axis and x-axis, and we can get the result of the vector. This can be C equals to x plus iy, since x is real number and iy is imaginary. Then let's see this vector. We call this vector as r. And look at this triangle. R and the x-axis made an angle, and we can state it as theta. So from this we can get the formula x equals to r cos theta and y equals to r sin theta. From here we can get the formula of C in the polar form. We know that C equals to x plus iy. So we change x into this one and y into this one. So we get x is r cos theta plus I times this one r sin theta. So we get r in the bracket cos theta plus I sin theta. And cos theta plus I sin theta, we can call it as cheese theta. R cheese theta. So the formula for polar form of complex number is C equals to r cos theta plus I sin theta equals to r cos theta. Now look at here. Remember that c equals to r times cos theta plus I sin theta. Here, r is the absolute value of c, or equals to the square root of x squared plus y squared. And theta is the argument of z, or we can write it as r z. And now let c is equals to r cos theta plus sin theta, and let c bar z bar equals to r times cos theta minus sin theta. Here, z equals to r cos theta, so we can get arc c equals to theta. And for this one, z bar equals to cos minus theta, since the symbol is minus, so we can find the arc c bar equals to minus theta. Here I have example 1, and the questions are: convert the complex number below into polar form, and we have the complex number is equals to 3 plus 3i. How we can get the polar form? Solution: first, draw the Cartesian diagram. Since c equals 3 plus 3i, of course, z is in the Cartesian diagram, and its coordinate x, y, with x is 3 and y is 3 also. So we make the factor 3, and we will see here, and this is this is being r, and this is being theta. Now the first one, we have to find r. R is equals to the absolute value of c equals to the square root of x squared plus y squared, or equals to 3 squared plus 3 squared equals to 9 plus 9 equals to square root of 18. Or we can write it as 3 square root of 2. And look at this triangle. We can make this one is 3, and this one is 3, and this is r, and this is theta. So the second one, we have to find theta. We can find theta. I will change this into this one. So this 3 and 3 is theta. Using tan is equals to, and theta equals to y over x, or equals to 3 over 3 equals to 1. So we can get theta equals to arc and 1 equals to p over 4. After we find r and find theta, so we can make the polar form like this. So we get polar form is c equals to, we put r, 3 square root of 2 times in the bracket cos p over 4 plus I sin p over 4. Now we have example number 2. Now z equals to 1 plus I times 1 plus I square root of 3 over negative 1 plus I. The question is determine the polar form of z and z bar. The solution for these questions, we have to make the polar form of each of these. So we have to split this one into 3 parts. Let's move to the part number 1. Part number 1 is I plus I, and then we write and we can analyze that x comma y equals to 1 comma 1, since there is no other numbers in I. So we can get r is square root of x squared plus y squared equals to 1 squared plus 1 squared equals to 1. And we can get tan theta is y over x, and we get 1 over 1, so we get tan theta is 1. So we can get theta is p over 4. And the part number 2 is 1 plus I square root of 3. We can analyze that x comma y is 1 comma square root of 3. So we can get the r is 1 square plus square root of 3 square equals to 1 plus 3 equals to square root of 4 equals to 2. And tan theta is y over x, that is square root of 3 over 1. So we get theta equals to p over 3. And for the last part, that is negative 1 plus I, is the coordinate is x comma y, and we can analyze that x is equals to negative 1 and y equals to 1. Here we can search r as negative 1 squared plus 1 squared equals to 1 plus 1 equals to Oh, I have made a mistake here. This is not 1, but this is may square root of 2. And here we get 1 plus 1 is square root of 2 also. So we get tan theta is 1 over x equals to 1 over minus 1 equals to minus 1, and we get theta equals to 3p over 4. Here we can get the polar form for each part. The first part, the polar form is C equals to R square root of 2, and then we use cheese here, so it will be cheese theta. This theta means cheese p over 4. And for the part number 2, we will get C equals to R is 2, cheese theta is 3p over 3. And the last part, we get C equals to square of 2 cheese 3p. After this, we reunite it again into C. C equals to the first part 1. We change it to this one. Square root 2 cheese, too much, cheese p over 4 times this one, 2 cheese p over 3 and over square root of 2 cheese 3p over 4. We can simplify this form into cheese p over 4 times 2 cheese p over 3 over cheese 3p over 4. So we got cheese p over 4, and we put the 2 here, and we get plus here since this is multiplication, and since this division, so we have minus 3p over 4. So this may get 2 cheese minus p over 6. So we will get 2 cheese minus p over 6. This is C. So for C bar, remember that arc C bar is the opposite of arc C. So with this, in this C, arc C is negative p over 6. So arc C bar is the opposite. C bar equals to 2 cheese p over 6. Okay, now we will discuss about the operation in polar form. In polar form, we have 3 operations. The first one is multiplication, And the second is division, and the last is inverse. Okay, let's we discuss about multiplication. Look at here. Let C1 equals to R1 cos theta 1 plus I sin theta 1 and Z2 equals to R2 cos theta 2 plus I sin theta 2, with R1 equals to the absolute value of C1 and R2 equals to absolute value of Z2, and for arc C1 equals to theta 1 and arc C2 equals to theta 2. Now look at the multiplication. We have multiply Z1 and Z2, so we multiply R1 cos theta 1 plus I sin theta 1 times R2 cos theta 2 plus I sin theta 2. Here we associate it, R1 times R2 and cos theta 1 plus I sin theta 1 times cos theta 2 plus I sin theta 2. This is same, and we simplify this form into, we multiply as usual, so we get cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 plus I cos sin theta 1 sin theta 2 minus sin theta 1 cos theta 2. And here, according to the properties of addition in trigonometry, we get for cos theta 1 cos theta 2 minus sin theta 1 sin theta 2 is equals to cos theta 1 plus theta 2, and for cos theta 1 sin theta 2 minus sin theta 1 cos theta 2 equals to sin theta 1 plus theta 2. So here, since theta 1 plus theta 2, and we can state it as one variable, plus I sin theta 1 plus theta 2 also, so we get this form as cheese. So we get R1 times R2 times cheese theta 1 plus theta 2. Remember that R is from the absolute value of C1 and C2. So here we get R1 times R2 equals to absolute value of C1 times Z2, which is theta 1 plus theta 2. So here for arc C1 times C2 equals to arc C1 plus arc C2, since here is theta 1 plus theta 2. Now we will discuss the division. Here we will divide Z1 over Z2, so Z2 not equals to 0. Z1 over Z2 equals to R1 cos theta 1 plus I sin theta 1 over R2 cos theta 1 plus I sin theta 1. Here we separate it first, so R1 over R2 times cos R1 plus I sin theta 1 over cos theta 2 plus I sin theta 2. So after that, we multiply this and this one with cos theta 2 plus I sin theta 2. Okay. So we get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2 plus I sin theta 1 cos theta 1 minus sin theta 1 cos theta 2. I'm sorry, this is not 1, but it should be 2. So after that, after we get this one, and this will be cos square theta 2 plus sin square theta 2, and we change this form and this form into this form from the properties of addition and subtraction in trigonometry. So we get R1 over R2 times cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So we get R1 over R2 times cheese theta 2 minus theta 1. And here, arc Z1 over Z2 equals to arc Z1 minus arc Z2 since this is theta 1 minus theta 2. Okay, now we will discuss about the inverse of complex number Z. Here, inverse any complex number Z, R, E, power I, theta. And the inverse of C is Z power minus 1. Since this power minus 1, so Z power minus 1 equals to 1 over Z. This equals to 1 over R cos theta plus I sin theta. And this form is multiplied by the conjugate, so we get cos I minus cos theta minus I sin theta over R cos square theta plus sin square theta. And here we get cos theta minus I sin theta, and because this form is equals to 1 according to the identity of trigonometry, so we get only R. So here we get 1 over R, which is minus theta. And for arc, the inverse of C, or arc 1 over Z equals to minus arc C, since the theta is negative. That's all about the operation in polar form.
Now we will discuss about exponential form of complex number. Before this form, we have discussed about Cartesian form and polar form, which the Cartesian form is Z equals to x plus iy, and the polar form is equal to r cosinus theta plus I sinus theta. And then in exponential, we have Euler formula. The formula is like this. Cosinus theta plus I sinus theta equals to e power I theta. From this formula, we can simplify the polar form. It can be Z equals to R e power I theta, and this form is what we call the exponential form of complex number. There are 3 algebraic operations in exponential form. So let Z1 equals to R1 e power I theta 1, and Z2 equals to F2 e power I theta 2. So the first operation is multiplication. If we multiply Z1 times Z2, it's equal to this R1 e power I theta 1 times R2 e power I theta 2, and this is equal to R1 R2 e power I theta 1 plus theta 2. And the second is division. When we divide z1 divided by z2, this is equals to L1 a power I theta 1 over L2 a power I theta 2. And this can be L1 over L2 a I theta 1 minus theta 2. And the last is the inverse. So the inverse of z, so it's like z inverse is equal to 1 over z, and this is equals to 1 over r a power I theta, and it's same with 1 over L a power minus I theta.
Okay, now we will talk about power of complex number. By applying rule for real number to complex number c equal to r times exponential I times theta, we will have this one, c power n equal to r power n times exponential I times n times theta, where n is equal to 0, plus minus 1, plus minus 2, and so on. Next, we will check this one. First, we have c equal to r times exponential I theta. And for the first, for n is element of natural number, z power n becomes, like usual, r times exponential I times theta power n. Because we applying rules for real number, this one become r times exponential I theta times r times exponential I theta, and so on. Until n times. In this one, we know that it is a complex number, and before that, we already learned about the product of complex number. After applying the product rule of complex number, we will get it is become r times rn, so on, also n times. And for this one, it become also exponential I theta times exponential I theta, and so on until n times. After that, we operate this as usual, and we will get this one is r power n times exponential n I n theta. And This formula also holds for n equal 0. And for the next, we will check for n element of negative integer. Maybe we will check in this side. For n is element of negative integer, we will have c power n equal to c power negative 1 times, power negative n. Note this one, negative n is element of natural number. Since this one is c power negative 1, we already knew that it is inverse of complex number, and we already learned before the value of this one is 1 over r times exponential negative I times theta over negative n. After that, we operated it as usual by applying rules for real number. 1 over r over negative n times exponential negative I and theta. And for the next, it will become r power n I'm sorry, this one should be plus, because minus times minus is plus, times exponential I and theta. And we move to the example. We have complex number square root of 3 times I. We will find the value of the complex number powered by 7. We know that the complex number in this question is in coordinate form, and we will change first into exponential form. In this one, we have x equal to square root of 3 and y equal to 1. From this, we know that it is in first quadrant, and the value of r is square root of x squared times y squared. It's equal to 2. And we find the value of tan theta is y over x. It is 1 over square root of 3, and we can change into 1 over 3 times square root of 3. And then we will find the value of theta is p over 6. And for the next, we will change into exponential form. The formula is z equal to r times exponential I theta. And we substitute the information that we already get before. The r is 2 times exponential I theta. And we already have the value of c, and then we find the power of c by 7. C power 7 is 2 times exponential I p over 6 power 7. And then we apply the formula that we already learned before. It's just apply the 2 power 7 times exponential 7p over 6i, and then it becomes 1 to 8 exponential 7p over 6i. Okay, we move to the example of roots of complex number. In here we have example, determine the roots of cube roots of negative 8i, and then sketch it in complex field. Let's go to the solution. First, we have let ZO is complex number, it is negative 8i. From here, we know that x equal to 0 and y equal to negative 8. And then we will have the value of R. R is the value of CO. We will have R is 8. And then since x is 0 and y is negative 8, we can plot it in Cartesian. It's just a sketch in here. So we will have that the theta is negative p over 2. After know this information, we move by input the information into the formula of roots of complex number. Let the zk is cube root of negative 8i. So we will have cube root of 8 times cosine negative p over 2 plus 2kp over 3 plus I sinus negative p over 2 plus 2kp over 3, where k is equal to 0, 1, and 2. We already know the formula of zk, so we change k in by 0, 1, and 2. For the first, for k is equal to 0, so it will be cosine negative p over 2 over 3 plus I sinus negative p over 2 over 3, and by operating this one we will get it is 2 cosine negative p over 6 plus I sinus negative p over 6. We know that it is not in rectangular form, so we change it by use this formula. X is r cos theta and y is r sinus theta. So r is 2 and cosine negative p over 6, and then it will be square root of 3, and for this one is 2 times sinus negative p over 6, and it will be negative 1. So it will be square root of 3 minus I. And then we do the same thing into k equal to 1 and k equal to 2. For C1, we will get the value is 2 cosine p over 2 plus I sinus p over 2. And we change it into rectangular form, we will get it equal to 2i. And for k equal to 2, we have C2 is equal to 2 times cosine 7 of p over 6 plus I sinus p 7p over 6, and it equal to negative square root of 3 minus I. That's the example.
In the power of complex number, there's the Moivre's formula. The Moivre's formula states that for x element of real numbers and n element of integer number, hold that cosinus theta plus I sinus theta to the power of n is equal to cosinus n theta plus I sinus theta, where I square is equal to negative 1. I is integer. I is imaginary. To prove the Moivre's formula, we use mathematical induction. The first, for n is equal to 1, it's true, where cosinus theta plus I sinus theta to the power of 1 is equal to cosinus theta plus I sinus theta. And then assume that it's true for some positive integer n. Then we must show that it's also true for n plus 1. So cosinus theta plus I sinus theta to the power n plus 1 is equal to cosinus n plus 1 theta plus I sinus n plus 1 theta. Since it's true by the hypothesis that cosinus theta plus I sinus theta to the power of n is equal to cosinus n theta plus I sinus n theta, then multiplying both sides by cosinus theta plus I sinus theta. And then by multiplying both sides with cos theta plus I sinus theta, we get this one. So we just multiply this and we get in here cosinus n theta plus cos theta minus sinus n theta sin theta. Why this is minus? Because in here is plus I times 2 plus I. So we get, because I is imaginary and I square is equal to negative 1. And here plus I sinus n theta cosinus theta plus cosinus n theta sinus theta. From trigonometry, we have the following, we have some angle identities. The cosinus n theta cos theta minus sinus n theta sin theta is equal to cosinus n plus 1 theta, and sinus n theta cosinus theta plus cosinus n theta sinus theta is equal to sinus n plus 1 theta. So for n plus 1, the formula is proved. In here we have an example for the Moivre's formula. Let z equals to square root of 2 plus the square root of 6i, and then determine the value of z power 4. Yeah, in here we have x is equal to square root of 2 and y is equal to square root of 6. Then we should find the r first. So the r is the square root of x squared plus y squared. And in here we have the r is equal to 2 to the square root of 2. And then find the theta by knowing the tangent theta. Tangent theta is equal to y over x, the square root of 6 over the square root of 2. In here we have the square root of 3. And to find theta, we use arcstan. The square root of 3 is equal to 60 degrees. So in here we have z is equal to 2 square root of 2 cosinus 60 plus I sinus 60. Then to find z power 4, in here we should use the De Moivre's formula. It's r power 4 cosinus 4 theta plus I sinus 4 theta. In here we have 2 to the square root of 2 power 4 cosinus 240 degrees plus I sinus 240 degrees. And in here we have 64 in times to negative a half plus I negative a half to the square root of 3. So to finding z power 4, here we use De Moivre's formula. It's 2 to the square root of 2 power 4 times cosinus 240 degrees plus I sinus 240. In here we have 64 times to negative a half plus I times negative a half power to the square root of 3, I mean. And in here we have 64 times negative a half minus a half to the square root of 3i, and equals to negative 32 minus 32 to the square root of 3i.
That's all the materials of complex number. Thank you for learning with us.
If you have any question, just comment below. Don't forget to like, comment, share, and subscribe. Bye!